right, we're ready to go to model number 3. And in this model, we're going to do a couple of things different. We're going to use every possible interaction that we can make and include it in the model. But we want to do that only with the variables that are significant. That is the variables that we obtained in model number 2. So let's say this is a stepwise model with interaction effects or with interactions. So remember what model 2 was. So let me show you a summary of model number 2, and that is the step.m2. These are the variables that were obtained to be significant. Just take a look at this variable. This is the missing value indicator that we created. It has a negative effect on the odds of responding to the donation request. We have, for instance, variables like the demographic median home value to have a positive effect on the odds of donating. So the more the median home value, then the higher the odds of donating. So we can look at this. These variables are the ones that appear to be more important, so we can focus on those. And we can check if there is any interaction effect between any of these two variables. Remember what interaction effects are from your regression class 291. You know that there is interaction between two variables when the levels of one variables are the effect that variables have on the response is affected by the levels of the other variables. So that's what interaction is. I would invite you to go ahead and take a look at the definitions one more time, and how you can note if variables interact with each other. But let's start doing this. Let's something handy that you can find is using the formula function in R. What it does is show you what that model is. So that would be the model that you use with every single predictor variable. That is handy because you don't have to, if you wanted to fit this model one more time, you don't have to go ahead and start writing variable by variable and separating it by pluses. So in this case, you have the formula right there. So one thing you can do is, in order to have the interaction effects, is you can copy and paste this formula. So let's create a new formula. We can do the formula function, and we want to copy and paste this. And what we're going to do is that we are going to raise these predictor variables to the power of 2. And what that would do is create every single predictor, and we're going to have now every single one of those interaction effects that we need. So let's do that. So now we have a new formula. We can take a look at it. Formula for F. And that is, again, the same thing that we have done. We are going to just go ahead and, if you want to look further into this function and into what the variables are really, because really what we are seeing here is just the square term, you can use the following code. You can say terms, and you want to take a look at the attributes from this formula. So you can do this we call it F, and let's put the terms the term labels in here. You don't need to remember this line of code, but this is only to check what the formula is right now. So this is the variables that the formula has. It contains the original predictors, which we call the linear terms. So you can see the predictors that you have in this stepwise model here, but also you have the interaction effects between those original linear predictors. So this is the interaction between gift count 36 and the status cat star all. So this is interaction between these two variables. Because we have everything on that F formula now, then we can check which one of these interaction effects is significant. So that's where we are going right now. We're gonna go ahead and we want to pass it through the stepwise method so that the stepwise method actually selects which variables are important. So we already have a null model. So you remember that we created these with no predictors. Now we have to create the model. I mean, we need to create the model that can go up to this upper value. It contains all of these variables. So let's call it complete model just to do it differently, not override default. So we can do gln and we can put f. So f is this whole formula. So we don't have to rewrite it one more time. So just writing f should already have everything in there. So we can do data is equal to training, and the family is now binomial. So that's our complete model. And then now we are going to do stepwise model number 3. And this is using the stepwise function just as we did before, starting with a null, and then the we can go the scope of the model to go from the lower to now the complete model. And we need to have this on the training data set and the direction, which is a stepwise method to do both. Let's put the trace equal to 0 so that we don't get all of the output in between. And this should be a model that contains every single one of these predictors. It's just basically checking on the background which of these predictors is significant. There's a couple of things to note here. It's likely that you can get models where the original terms are not significant, and the interaction term is significant, and then the original terms are not. That's likely to happen, but let's not worry about that right now. So let's take a look at the model number 3. So this is model number 2, so let's take a look at model number 3. So now this model contains some actually some interaction terms. So the stepwise method under all of these variables that were here, so we have more than so we actually have 55 possible variables, is selected a few of them to be significant. You can see that we improved upon the residual deviance. We need to, and again, this is model adequacy. We need to check how that translates into validation performance. So that's what we're going to do now. Let's go ahead and take a look at the predictions. And to keep the same conventions, the same namings, let's call it PM3. So that's the prediction for model number 3. And we can do the predict function using our model, which is step model 3. And again, one of the limitations of doing these is that you would have to remember the objects that you create. So I would strongly encourage you to keep track of it in a page or a spreadsheet or something like that, so that you don't get confused. But now this is the predictions for the validation for model number 3. We're going to do the same thing, but predict also the training data set. So let's change this to be the training. And we want to now take a look at the performance. So that's validation performance. So we're gonna do let me check naming conventions we have: R1 train, R1 validation, R2 train, R2 validation. So let's do R3 train, and we are going to use the RC, and basically we're going to do the training target B, and we need to have here the predictions for model 3 train. So let's take a look at the AUC. You can see 62, and then let's do the same thing for the validation. So let's call it R3 valid. And let's take a look at the R3 valid AUC. So we can see that's 60.8%. Right, so now we have our model number 3 complete. So basically we have the 3 different models. Now we have to check or select which is the best one, and that's going to be on the next